Hello students, welcome to maths classes. Today we are doing class 11 NCERT exampler, chapter 2, that is relations and functions, and this is your question number 6. Given that the relation R is x is related to y, first of all x and y both must be whole numbers, and satisfying this condition that x square plus y square should be equals to 25. So you are supposed to find the domain and range of R. So your relation R is defined from the set of whole numbers to the set of whole numbers such that R contains those ordered pairs x and y both must be whole numbers. Satisfying this condition, x square plus y square is equals to 25. So the relation R is from the set of whole numbers to the set of whole numbers. Okay. So first of all, take x as 0. So if we satisfy 0 ka square plus y ka square is equals to 25. So y square is equals to 25, y is equals to plus minus 5. But minus 5 is not in the set of whole numbers. So 0 is related to 5. Then next is 1. 1 ka square plus y ka square is equals to 25. So y square is equals to 24. So y is equals to plus minus root 24, which is not a whole number. So 1 is not related to any other whole number. Then take 2. 2 ka square plus y ka square is equals to 25. So y square is equals to 21 and y is equals to plus minus root 21. Again it is not a whole number. Then try for 3. 3 ka square plus y ka square is equals to 25. So y square is equals to 25 minus 9 is 16. So y will be plus minus 4. Minus 4 is not a whole number but 4 is a whole number. So 3 is related to 4. Next try 4. 4 ka square plus y ka square is equals to 25. So y square is equals to 25 minus 16, that is 9. And y will be equals to plus minus 3. Minus 3 is not a whole number. So 4 is related to 3. Then next try for x. Take x is equals to 5. And in this case y square is equals to 0, so y is equals to 0. So 5 is related to 0. And if we take 6, so y square will be coming negative, which is not possible. So these are the ordered pairs in this relation. So R contains 0 is related to 5, 3 is related to 4, 4 is related to 3 and 5 is related to 0. So the domain of R is 0, 3, 4, 5 and the range of R is also 0, 3, 4, 5. Your next question is question number 7. If R1 is a relation where x is related to y, satisfying the condition y should be equals to 2x plus 7, x should be a real number and lying between minus 5 to 5 is a relation, you have to find the domain and range of R1. Now, first of all consider R1. R1, the domain, what is the domain of R1? X is a real number lying between minus 5 to 5. First of all, x is a real number between minus 5 to 5. So the domain of this relation R is the whole real numbers lying between minus 5 to 5. Now, what is the range? For every real number lying between -5 to 5, we are going to check where the limits of y. Consider here we are not supposed to write this relation in roster form because it is an infinite relation. So consider x is lying between -5 to 5. So 2x will lie in between -10 to 10. If we add 7 into it, so 2x plus 7 will lie in between 17 and -3. And what is 2x plus 5? Is y. So y is lying between -3 to 17. So this is the range of your relation, that is -3 to 17. Your next question is question number 8. If R2 is a relation where x is related to y, first of all x and y must be integers, and satisfying this condition x square plus y square is equals to 64. So you have to define your relation R2. So R is a relation from the set of integers to the set of integers such that x square plus y square must be equals to 64. So x is coming from the set of integers, y is also coming from the set of integers. So first of all, let us take, we have positive or negative both integers. If we take x as 0, first of all consider x as 0. So 0 ka square plus y ka square is equals to 64. So y will be coming plus minus 8. So 0 is related to plus 8 and minus 8. Okay. Now take x as 1. If we take x as 1, then 1 ka square if we subtract from 64, so it will give you 63, which is not a perfect square. So 1 is not related to any integer. Even 2 is not related to any integer. 3 ka square is 9. If 9 is subtracted from 64, we won't get perfect square number. Then we can try for 4. 4 ka square is 16. If we subtract 16 out of 64, we won't get a perfect square number. Next is, we can try for 5. Then 5 ka square plus y ka square is equals to 64. So y is equals to 64 minus 25. 64 minus 25 is 39, which is not a perfect square number. Then we can try for 6. 6 ka square plus y ka square is equals to 64. Again, we are not getting any perfect square number. 64 minus 36. 64 minus 36 will be 28, which is not a perfect square number. So similarly we can try for 7, and then we can try for 8. So 8 ka square plus y ka square is equals to 64. We will get y is equals to 0. And we can also try for minus 8 also here. And again we are getting y is equals to 0. So 8 is also related to 0, and minus 8 is also related to 0. So your relation R2 is minus 8 is related to 0, 8 is related to 0, 0 is related to minus 8, and 0 is related to 8. Your question number 9 is, if R3 is a relation where x is related to modulus x, where x is a real number, then you have to find the domain and range of R3. Now x is a real number, so it is an infinite relation, so we cannot write it in roster form. Now the values of x will give you these values, possible values of x will give you the domain. So x belongs to, since x is a real number, that implies the domain of your relation R3 is the set of real numbers. Again, now the possible values of modulus x will give you the range. When x belongs to R, modulus x, since modulus of x is always greater than equals to 0, that implies, so x belongs to 0 to infinity. Okay. Modulus x belongs to 0 to infinity. So the range of R3 is equals to 0 to infinity. Now question number 10 is the given relation a function? You have to give reasons. Your first relation is defined as h, where 4 is related to 6, 3 is related to 9, minus 11 is related to 6 and 3 is related to 11. Here you can observe that 3 is related to 9 also and 3 is related to 11 also. So 3 has two different images. But for a relation to be a function, every element in the domain must have a unique image in the codomain. So it violates the condition, so it is not a function. Secondly, your f relation is defined as x is related to x, where x is a real number. So for every real number, it is related to itself. So every real number is distinct, so every real number has a unique image, so it is a function. No element in the domain can have two images in the codomain. Next, that in the relation G, n is related to 1 by n, where n is a positive integer. So for every positive integer, the image is unique 1 by n. 1 by n is not defined only when n is 0, but your domain is the set of positive integers which does not contain 0. So if 2 is related to 1 by 2, 2 by 5 is related to 1 by 5. Okay. So every element in the domain must have a unique image, so it is a function. Next, in the relation R, n is related to n square, where n is a positive integer. So positive integers are 1 is related to 1, 2 is related to 4, 3 is related to 9. So every positive integer has a unique image in the codomain, so it is a function. And in the relation T, x is related to 3. Where x is a real number. So for every real number, you have a unique image 3. You do not have two distinct images in the codomain. For every real number, you have a unique image 3. But it is all elements are related to 3, that doesn't matter. But every element in the codomain must have a unique image which is satisfying. This condition is satisfying here, so it is also a constant function.